Okay, this is part 2 of solving rational equations with extraneous, and we're just adding this with extraneous solutions today. Okay, so that's the part 2 of it. Now, we're just gonna have to do part 1 or example 1, example 2, or just stuff that we have to know how to do in order to complete the rest of today's stuff. So, anytime we have an x squared with another x, we want to end up factoring this. But in order to factor, we have to set it equal to 0 because you factor to find the zeros. So we're going to subtract the 6x from both sides to get the left side equal to 0. And then you have 3x squared plus 15x. Now when we factor this is a two-term polynomial, we find the GCF first. Well, both of these have a GCF of 3x, and what's left over is your x plus 5. And it's still equal to 0. Well, now that we've factored it, we can find what makes each of these 0. So 3x, if I set 3x equal to 0, it's 3 times x is equal to 0. That means x is equal to 0, okay, because 3 times 0 is 0. Then, if you set x plus 5 equal to 0, you would know that negative 5 is your solution because negative 5 plus 5 is equal to 0. So your two solutions for this example over here are 0 and negative 5. Jump over to the example 2. If I am solving for x in this case, the x squared is on the left side, so we're going to move everything to the x squared side. So I'm going to subtract 20 to set the right side equal to 0. Either way, we set it equal to 0. And now what we have is 2x squared plus 9x, and 9 minus 20 is a negative 11. Now that we have three terms, we're going to factor this by using the x factor. Okay, so a times c, 2 times negative 11 is negative 22, and 9 is your b value. So the two numbers that are going to multiply to get negative 22 and add to be 9 are, well, it's going to be a 2 and 11, because 2 times 11 equals 22, but it's a negative 22. So which one of those is going to be negative? The 2. So that negative 2 plus 11 is a 9. So we are going to break this up. Here we're going to break this up into the negative 2x and a positive 11x. But the 2x squared and the negative 11 on the back side don't change. Now we're going to group the first two and the last two terms and factor each one separately. The 2x squared and negative 2x, they both at least have a 2x in common, so we're going to factor out the 2x. And what's left over would be an x minus 1, so that if I distribute the 2x back in, I would get the 2x squared, and 2x times the negative 1, I'd get to negative 2x. Now we want the x minus 1 to be the same factor on both of these. Now the factor that you would have to take out of the 11 and the negative 11 would just be a positive 11, so that 11 times x makes 11x, and 11 times negative 1 is negative 11. And so now our two factors are x minus 1 and the remainder of what we have left over, 2x plus 11. Now that's just the equation that's equal to 0. And I circled this. I probably shouldn't have circled it just to make sure we are still solving for the zeros. So if we have x minus 1 equals 0 and 2x plus 11 equals 0, we're going to solve each of these to find our solutions. Well, this one is just x is equal to 1, because if I add 1 to both sides, you would get 1. Now for the other example, or the other factor, you have to subtract 11, and then you would also have to divide by 2 after that. So x is going to equal negative 11 over 2. So your two solutions after we factored are equal to 1 and negative 11 over 2. So now we're going to include extraneous solutions with this next example. So we're going to solve each of these rational equations, state all excluded values, and determine any extraneous solutions. So we first have to define what an extraneous solution is. So any extraneous solution, it's any excluded value, which we know is a 0 in the denominator. And this excluded value is also a solution. Okay? So essentially it's not a solution if you can exclude it, but it will, when you solve it algebraically, become a solution. So we'll talk about that, and here's an example where you will have an excluded value that's also a solution, called it extraneous. So for this first example 3, we have an equal sign with these rational expressions, so we want to eliminate the denominator. So this 5m squared needs to multiply into each term to get rid of the 5m squared in the first term. So that gets rid of the 5m and the 5m squared. Now if I go over to the next fraction, the 5m squared is also a 5m squared, and that eliminates in that fraction. However, in this fraction, the only thing that eliminates, that we can reduce out of the numerator and denominator, is just the 5. The m squared stays. So if we've eliminated all denominators, nothing else to reduce in the denominator, just write what's left over. The m plus 1 is in this first one, and that is equal to 1, but this one is plus, there's a 1 and also an m squared left over, so it's 1 times m squared. Now you don't really need to put this m squared here, so in the future I'm just going to write that as m squared. Now we have an m squared, and so in order to solve this, we're going to move everything and set the equation equal to 0, move it to the m squared side, and then factor to solve for the solutions. So to get rid of m, subtract m, and to get rid of 1, we're going to subtract 1. So I'm going to subtract m and subtract 1, and the reason I stack this 1 because that's a like term, and that gets you 0 on the left side is equal to 1 minus 1 is 0. But then if I look at m squared and I subtract m, these are not like terms because they don't share the same exponent. So I'm going to keep these separate. So this is just plus 1m squared minus m. Now I'm going to rewrite this. You don't really need this 0. I just wrote that just because that's the like terms added together. So really this is 0 equals m squared plus m. Once we have it simplified, we are going to factor this. And so this 0 is equal to, once we take the GCF of m out, you just get m plus 1. Because m would multiply to get m squared, and m multiplies to the 1 to just get 1m. And so your solutions are m is equal to 0, and I'm just setting the first one equal to 0, and when m plus 1 is equal to 0. Well, this is easy. This factor right here, the only thing that makes m 0 is that you input 0. So one solution is m is equal to 0. And the other solution, when I have m plus 1 equals 0, you just have m equals negative 1 as your solution, because negative 1 plus 1 is 0. Now this is great. These are both solutions when we solve it algebraically. But if I go back up to the original equation and we talk about the excluded values, we know that excluded values are zeros in the denominator. Because you can't divide by 0, that makes the expression or the fraction undefined. So if I'm jumping over to this m squared, the values that I would substitute in for m to make 5 times m squared 0 are just 0, because 0 squared is 0 times 5 is still 0. Same for this one. Now 5 doesn't have a variable, so there's no m in that, so there's nothing that m can't be. So the excluded values, m cannot equal 0, because m is equal to 0 makes both of the denominators in the first and second term equal 0. So n cannot equal 0 is an excluded value. Now if I interpret that back through to the solution, we also have an m equals 0 as a solution. So really this is what we're going to call an extraneous solution. So even though algebraically it solves out to be a solution, it is part of the excluded values that would make the denominator 0, and so we can't have this as a solution. Okay? So the only solution that we are allowed to have for this expression, for this equation, is just m is equal to -1, because x equals 0 was excluded. Similarly, we're going to do this example 4. Okay? Now, I am going to, before we even start eliminating denominator, we're just going to identify excluded values first. Excluded values. Okay. So we can do that, and then when we solve it, we can just look at the excluded values and say, oh, it is one of these, and then we can eliminate that and say that's not a solution. But before we do that, we're trying to find zeros in the denominator. Now, right away, we can't find a 0 of r squared plus 3r plus 2 unless we factor. So I'm going to factor this. Now, this is the method when a is equal to 1. So there are just two numbers that multiply to get 2, and the same two numbers add to be 3. So that is r plus 2 and r plus 1. Because 2 times 1 is 2, and 2 plus 1 is 3. So those are your two factors. I'm going to eliminate the denominator and just replace it with r plus 2 and r plus 1. Now there's already an r plus 2 and an r plus 2 in these other ones, so the excluded values r cannot equal, for this first one, -2. And that is because of the factor x, or r, not x, r plus 2. Because -2 makes that a 0. Also, there's another excluded value of r is equal to -1. And I know that r plus 1 is not a factor of either of the other two fractions. However, as soon as it's a excluded value in one, it's an excluded value for the whole equation. So you also have r cannot equal a -1 because of the factor r plus 1. So in this case, we have two excluded values. Now let's solve this equation normally by eliminating the denominator. So to get rid of r plus 2 and r plus 1 in the denominator, we're going to multiply by r plus 1 and r plus 2 in both, in the numerator as well, and in all terms. R plus 1 and r plus 2, r plus 1 and r plus 2. Now the first one, the r plus 1 and the r plus 2 is eliminated. So there's no denominator left in this first term. But in the second term, the r plus 2 only eliminates. So you're still left over with this r plus 1 and this 1. And then in the last term, the r plus 2 and the r plus 2 eliminate, but you're also left over with an r plus 1, just like the second term. So now if we simplify all of these, or I'm just going to write what we have after we simplified our eliminated denominators, we have a 4 left over in the first term. That's it. Now we are subtracting 1 times r minus 1. And this is important. This subtraction is really attached to this 1. So it's subtracting 1 times r plus 1. And that is equal to, and you can assume that the r plus 3 is in parentheses, r plus 3 times r plus 1. And these have to be in parentheses to identify that we are multiplying these two together. So we're going to end up foiling this. And now I'm going to move on from this. Okay. The -1, since we are subtracting 1 times this number, we have to distribute that -1 into both of these. So this really becomes 4 minus 1r, and then -1 times 1 is a -1. That is equal to the multiplication of r plus 3 and r plus 1. Well, r plus 3 times r plus 1 requires the FOIL method, so I'm going to multiply r times r to get to r squared, and then the r times the 1 to get to plus 1r. Then I have to do the same thing with the 3. 3 times r is plus 3r, and 3 times 1 is plus 3. I'm going to now combine like terms. So now the 4 minus 1 is 3, and then we still have -r. So we have 3 minus r on the left side is equal to the r squared. There's no other square terms, but there is an r and a 3r to make 4r, and then plus 3 at the end. Now that we've added all like terms and we have this r squared, we want to move everything over to the r squared side and set the left side equal to 0. So I'm going to subtract 3 and add r. That's going to get the left side equal to 0. So subtract 3 and add r. That's going to eliminate these, and we're going to have 0 is equal to r squared plus 5r, and then 3 minus 3 is just going to eliminate. So all we have now is r squared plus 5r, and I'm just going to factor this. R is the GCF, so r plus 5 is the remainder, or what remains is the other factor. And our two solutions that make r equal 0 is 0, and the other one, r is equal to -5. These are the two solutions. Now, you have to remember, after you find the solutions, after stating excluded values, we have to see, do any of these solutions, or are any of these solutions excluded values? Now, if you look, r cannot equal -2, and r cannot equal -1. That is not neither of these. So this equation actually has two solutions. So we have no extraneous solutions. And the two solutions, r is equal to 0, and r is equal to -5. I would like you guys to do this next one on your own. Let's see what you can do, and then you can check your answer later. So pause the video now, and then you try it, and then let's see what you got, and then you can unpause and play it and see what we got here. So I'm going to solve for this. First, I'm going to find the excluded values, which are zeros in the denominator. Before I find zeros in the denominator, I have to factor these fractions. The n squared minus 2 and the n squared minus 2 stays the same. So this has a GCF of n, and this makes n minus 2 what's left over. So when I distribute through, I get back to n squared minus 2. So I'm going to say I've eliminated the denominator, or I've changed what the denominator looks like. Not eliminated yet. I haven't eliminated it yet. Okay, the n minus 2 also, we've already just talked about that. That's n minus 2. Okay, so both are the same. And this denominator over here is just 1. We don't really need the 1, but if you want to put it, it just reminds yourself that there is a 1 in the denominator under the 5. So now our excluded values are 0, because that makes n equal 0, and 2. So n cannot equal 0, and n also cannot equal 2. And that comes from the factors of the denominator when we took the GCF out of n squared minus 2n. Now the next step is just going to be solving it, right? We have to set this equal to something without denominators. So we are going to try and eliminate the denominator by multiplying both by n and n minus 2. Multiplying by n and n minus 2. Multiplying by n and n minus 2. That eliminates the n and the n minus 2 for both the first term and the second term. But no term of the n and the n minus 2 gets eliminated with this 5. So we're going to just rewrite everything that is left over. All that's left over in the first term is 6n minus 4. And then all that's left over in the second term is this negative, or this 4 minus, or n minus 4. Now, remember, this negative is important. This negative is going to come up here and distribute into both of these. So there's a reason I'm putting this in parentheses here, because it's going to save us some, it's going to make sure everything's all correct, save us some confusion there at the end. So 6n minus 4 is what's left over on the first term, minus an n minus 4. And that is equal to 5 times n minus 2. Now I'm going to distribute this negative 1 into both of these. So we have 6n minus 4 minus n plus 4, because the negative 1 times the negative 4 is in positive 4. Now, these are three terms multiplied together. So I'm going to multiply 2 at a time and then multiply and distribute this. This right here, 5 times n, is just 5n. Then I'm going to multiply the 5n into the n minus 2. Now you might be able to see that you can just do this 2 steps in one, but I'm going to do it in 2 different steps. Now we're going to distribute the 5n into the n and then the negative 2. And then over here I'm going to add the like terms. So we have a 6n and a negative 1n to make 5n. The 4 and the negative 4 just makes plus 0. And again, you don't have to put that plus 0, but if it helps you understand what's going on and add like terms, you can. Now the 5n multiplied by n is 5n squared, and the 5n times the negative 2 is negative 10n. Now we have a quadratic. We know it's quadratic because there's an n squared. So I'm going to move everything over to the left side, from the left side to the right, to set it equal to 0. So I'm going to subtract 5n, and get 0. So this left side equals 0 is 5n squared minus 15n. And the last step, 0 is equal to, take the GCF of both of these, 5n. What's left over is n minus 3. And so our solutions, what makes 5n 0 and what makes n minus 3 0? So 5 times 0 is 0, so n is equal to 0. And n minus 3, that makes n equal to positive 3, because 3 minus 3 is 0. So these are the two solutions, 0 and 3. However, we have to check to see if these are excluded values. And you look up front, n cannot equal 0 from the denominator, makes 0 the denominator originally. So this n equals 0 is an excluded value. And so the only solution is n is equal to 3. So hopefully you got somewhere close to that. The trickiest part, I would say, was this negative. It has to distribute into the n, and the negative has to distribute into the 4 to make a positive 4. Now the last one's kind of I don't want to say word problem, but it's something that deals with this function notation of h of t. Okay, so what is the value of t that makes the function h of t equal to 7 if the function has this given equation? So essentially what we're doing is just replacing 7 for h of t. So if h of t is equal to 7, all this is just saying 7 is equal to 4t all over t plus 1 minus 2 over 3. All I've done is just set this equation equal to 7. And we're going to do the exact same thing. I'm going to first state the excluded values. And those excluded values are what makes the denominator 0. Well, there's only one variable in the denominator, and that's t plus 1. So the value that makes the denominator 0 is negative 1, because t equals negative 1 plus 1 is equal to 0. Now we're just going to eliminate all denominators. So in order to do that, 7 is really 1. You don't really need to eliminate the 1 as a denominator, but we do need to eliminate t plus 1. So I'm going to multiply by t plus 1. Multiply by t plus 1. Multiply by t plus 1. Oh, that eliminates the denominator here. This stays. That didn't eliminate over here. So we have a t plus 1 and a 7. All that we have left over is a 4t, and we have a negative 2t plus 1. So I'm going to rewrite this again. This is 7 times t plus 1, and that is equal to 4t, because the t plus 1 is eliminated, minus 2 times t plus 1. But this 2 is still divided by 3. So we still have that denominator of 3 left over. So I am going to eliminate the 3 by multiplying all terms again by 3. And these don't eliminate with anything. So I'm going to just multiply this 3 with the 7 right away to say this is 21 and the t plus 1. 3 times 4 is 12, so equals 12t. And then this 3 eliminates, so all that we had left over was just a negative 2t plus 1. Now when I distribute all this, I'm going to take the 21 and distribute this, the negative 2, I should say, the negative 2, and distribute all of that. And you get 21t plus 21 is equal to 12t minus 2t minus 2. Now I'm running out of room on my paper, so I'm just going to go over here real quick. There is no t squared anywhere. So when I add like terms on the left side, 21t and 21 stays the same. 21t plus 21. But on the right side, I have a 12t and a negative 2t. So 12 and negative 2 equals a positive 10t, and the negative 2 doesn't change. Now solving this equation, I'm going to subtract 21 from both sides, and I'm going to get the t's to this side. I don't have to set it equal to 0 anymore because I don't have an x squared. And then I'm also going to subtract the 10t from both sides and get 21 minus 10 to be 11t equals negative 21 minus 21, negative 2 minus 21, so negative 23. And once you divide by 11, t is equal to negative 23 all over 11. That is your solution. It is not an extraneous value, so we're good. This is the solution. That's a check mark.